Normalizing flows, NFs, are powerful generative models that learn a bijective mapping between a simple latent distribution, like a Gaussian, and a complex data distribution, such as natural images. This invertibility allows for both efficient sampling and density estimation. However, a key limitation is that standard NFs often struggle to learn semantically meaningful representations. While they can generate realistic-looking images, the intermediate features within the flow don't necessarily correspond to identifiable object parts or high-level concepts. This lack of semantic alignment impacts the quality of the generated samples and limits their utility for downstream tasks. The core insight of this paper is that we can leverage the invertibility of NFs to enforce semantic consistency during the generative process. The authors propose reverse representation alignment. Instead of only focusing on transforming the input towards the data distribution, they encourage the intermediate features in the reverse pass, the generative pass, to resemble features extracted by a pre-trained, semantically aware vision model. Think of it as providing the NF with a semantic compass guiding its generation process. Specifically, at certain layers in the reverse flow, the features are extracted and compared to the corresponding features extracted from the generated image by the pre-trained vision model. A loss function, such as an L2 distance or cosine similarity, is used to minimize the difference between these features, effectively aligning the NF's internal representations with the vision models. This flowing backwards encourages semantically meaningful feature disentanglement in the generative process. Furthermore, the authors introduce a novel, training-free, test time optimization. By perturbing the latent code Z and optimizing for a specific class embedding from the vision model, they evaluate how easily the NF can generate images of that class. This provides a direct measure of the NF's embedded semantic knowledge and serves as a diagnostic tool. The paper demonstrates that reverse representation alignment significantly improves the generative quality of normalizing flows. They achieve state-of-the-art FID scores on ImageNet 64 by 64 and 256 by 256, indicating a substantial leap in image realism and diversity. Importantly, the test time optimization shows a significant increase in classification accuracy, confirming that the flowing backwards approach leads to NFs with a much stronger understanding of image semantics. This has implications for using NFs not just as generative models, but also as powerful representation learners for downstream tasks, bridging the gap between generative modeling and discriminative tasks.